Hello, this is Mr. Kenzie's Integrated Algebra class, day 3. We're going to continue our discussion with quadratics and talk even more in detail about our roots. So today, our roots, as you can see, or they cross, the parabola across the x-axis, and occurs when y is equal to 0. That's why it's also known as the zeros. We're going to solve for the roots of the parabola, set the equation equal to 0, and then get your zeros. Take a look here. This would be 0 roots. This would be imaginary. I'm just going to write that here. So these would be imaginary roots. These would be 2 roots, and this would have 1 root. That's where across the x-axis. Now looking at this very first question, you are going to do this one on your own. So we're going to skip it for right now. And we're going to turn to the next page. On the next page, all right, we're going to graph these parabolas. Now I'm going to look at number 2. All right, now looking at number 2, we notice that the a value is negative. That means we're going to have a maximum. It's going to be like an upside down U. The first thing that we need to do here, all right, is we need to find our axis of symmetry. So we have x is equal to negative b all over 2a. Our b value is negative 2. Our a value is negative 1. So we simplify this, negative 2 all over 2 times 1. That's going to be x is equal to negative 1. For this one, we'll have x and y. So I'll have negative 1 here as part of my turning point. And I'm going to take the 4 values that are less than. So we have negative 2, negative 3, negative 4, negative 5. Now, all of these will fit on the graph for this one. Then we have 0, 1, 2, and 3. Now I'm going to go to my calculator, plug this in into y equals. When we do that, we will get negative 8 here, negative 1, 4, 7, 8, 7, 4, negative 1, and negative 8. So we're going to graph this. So we have negative 5, negative 8. We then have negative 4, negative 1. We have negative 3, 4. We have negative 2, 7. Negative 1, 8. And then obviously it just repeats over the axis of symmetry. The last point that'll fit will be 3, negative 8. So now we're going to make this U shape, upside down U shape I should add. Now, it's probably a good idea that you use pencil in case you make a mistake. Put arrows at the very end, and then label this. Y is equal to negative x squared minus 2x plus 7. So we're going to look here, and it says, what are the roots? Now, we're going to do that in a second. Let's describe them first. All right, or to start them. We know there's 2 roots. We know from here there are 2 roots because they cross the x-axis in 2 spots. Now, we know they're real because once again, they do cross the x-axis. But we don't know if they are irrational or not. So we're going to go to our calculator. So from our calculator, I'm going to plug in y equals. I'm going to plug in negative x squared minus 2x plus 7. So when we graph this, you should get a very similar shape that we had. Now, if you take a look, they do not cross at the exact point. And I also know that because if I go to my table, so second table, when y is 0, it doesn't show up. That means that our roots are going to be decimal values. So I'm going to push second, and I'm actually going to trace this right now. So if I trace this, I'll be able to see. Now, this one doesn't go exactly on the line. All right, so because it does not go exactly on the line, we're going to have to use a function that we talked about earlier this year and you've talked about in years previous. We're going to push second trace. I'm going to choose choice 2 for 0. And I'm going to go down here, so as close as I can get. Now, I can't get all the way to the line or right on the line because of the pixels in the calculator. So I'm going to get as close as I can. And now it says left bound, so I want to push the left arrow one time. Now it says right bound in the bottom left corner. So I'm going to go as close as I can. I want to push to the right one time. Push enter. Now it's going to say guess. So that's as close as I can get. I'm going to push enter there. So my root is going to be 1.8284271. That's going to be irrational. Now I'm going to find the other one, and then I'll write this down in a second. So I'm going to do the same thing. So second trace. I'm going to use choice 2 again for the 0. But this time, I'm using the left and the right arrow. I'm going to go to the other root. So I'm going to go as close as I can. Now that one's pretty close. But just in case, I'm going to show you how to do this on the calculator. Go as close as you can. Push to the left once. Now it says right bound. Push to the right once. Now I'm going to guess. I'm going to get as close as I possibly can. I'm going to push enter. And if you notice, the y is not exactly 0. So we're not exactly on the line. But now we are. So our zeros, I'm going to go to my paper, are x is equal to negative 3.828427. And x is equal to 1.8284271. Now, those numbers, they do not terminate, they do not repeat on the calculator. As you can see, they stop there, and that's just because the calculator can't go on forever. So these will be irrational roots. And usually, if one of the roots is irrational, the other one will be as well. This one right here, all right, you're going to do number 1 and number 3, but I am going to start off number 3 for you. So for this one, we have x is equal to negative b all over 2a to find our axis of symmetry. So we have our b value, which is 1, a value, which is also 1. So we are going to have a fractional or a decimal value for our turning point. So I'm going to put our table here. So this is negative 0.5. You can write it as a fraction if you would like. And then you're going to have to find this by hand. So you're going to take negative 1/2 or negative 0.5 and plug it in here. So to find our turning point by hand, if y is equal to negative 0.5 squared plus negative 0.5 minus 4. And once again, that's just taking this x value and plugging it in. Now you're going to do the rest of that one on your own and then describe what kind of roots they are and what are the roots. So you're going to do the warm-up and then question 1 and question 3 on your own. Thank you.